Hey everyone, thanks for joining us for the next session of our RAG Deep Dive series, RAGChat Multimedia Data Ingestion. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our speaker today, Pamela. Thank you so much for joining us.
Hello, everyone. Welcome to the RAG Deep Dive series, to our session on multimedia data sources and how to handle those in RAG. You can grab the slides for this session from this URL here, and we'll post this in the chat so that you can reference the slides whenever you'd like. I am Pamela Fox. I'm from Python Cloud Advocacy at Microsoft, and I'm your speaker for most of these streams, sometimes joined by guest speakers, but today, just me. And if you are new to this series, we have lots of great topics. So basically, in this RAG Deep Dive series, we are diving into our most popular RAG solution for Azure, which is an open source Git repository that brings together Azure OpenAI, Azure AI Search, and other services like Cosmos DB, Document Intelligence, Blob Storage, etc., to make a really full-featured solution. So in this 11-part series, we're diving into different features of this repo and, really digging deep into each of the features and really trying to understand it and explain how they work, how you can use them, and how you could incorporate them into your RAG application. Now, many of you are probably actually using this repo itself, but also, the things we're talking about, you could apply to your own code bases as well. So you can register for all these sessions at this URL here, aka MS RAG Deep Dive Register, so that you can join us for all of them. These are always recorded on YouTube, so if you miss any, you can just go back, watch them on YouTube, and catch up. So talking about our RAGChat solution, for those of you who are new to it, you can see the URL here is for the repo, aka.ms/RAGChat will bring you to the GitHub repo. And that's where you can get all the code and get it deployed. Now, this repo does, what you expect is for RAG, which is the ability to answer questions about your own data. We started off with some sample data, which is, like HR documents, but you can take the repo and then put in your own data, and your RAG can be on, whatever it is, sales data, government handbooks, product details, it can be on so many different things, right? And then you can also enable optional features, right? So today we're going to be talking about a couple different optional features for handling multimedia documents. And then throughout this rest of the series, we'll be talking about more of those optional features. We also have live demo that you can check out now that is working if you want to see how it works. So I'll just go to the aka, so aka.ms/ragchat/demo. And here it is. You can see we have a chat tab, which is when we want to have actual, multi-message conversations, and then an ask tab, which is just simply Q&A with no conversation history. And yeah, we can ask a question here. Just click on one of the sample questions, and it's going off and getting the best results for that, and then streaming in an answer. And then when we see the answer, we can click on that answer and see the exact page pop up here where it got the answer from. So this is our basic RAG setup. So we're going to be building on top of this RAG in this session. And so I'm going to start with just talking about what does a single turn RAG flow look like. So actually what happens in this ask tab here. So if I, ask what does a product manager do? And then I get back this response here. So how does this actually work? What does it do behind the scenes? So we're going to go through it, just the simplest RAG flow that it has, just to make sure that anyone new to the repo understands what it's doing. So we get a question. So actually, let's do this question. Is there any correlation between oil prices and stock market trends? Because we're going to use this throughout our demos here. So is there any correlation between oil prices and stock market trends. Okay. All right, and so we get an answer saying that there is a correlation between oil prices and stock market trends, and it even gave us an actual correlation, and we could go ahead and look at the citation for that and see what it's linking to here. Okay, so what happens is we get that user question and we send that to an embedding model, the Azure OpenAI text embedding model, and we get back a vector. We then send both the user's text question and that vector to Azure AI Search, and we do a hybrid search with semantic ranker in order to get the best results. And we get back the results. We usually ask for 3 results, but we could ask for more results if we wanted. And then we send the original user's question and those results to the language model. In this case, it's GPT-3.5 Turbo, but we could use 4.0, we could use 4.0 Mini. Any powerful enough language model can then answer that question. And then we get back our answer. So that was just asking a question about the text in a document. But what if our documents have images in it? Can we ask questions about those documents that have images and get good answers that actually reference the content of those images? So that's the big thing we're talking about today, is how can we RAG on documents with images? Now, I called this multimedia because I couldn't figure out what to call it today. So you might be thinking also video audio. I'm not going to be talking about video or audio today, but I do think some of these same processes could also work with video and audio, and I think we'll see more of that in the future. Today, I'm focusing on documents with images inside them. So we're going to talk about, what these documents might look like, 2 different approaches that we have in this repo, and how you can use them separately, and also how you could use them together, and what the benefits and drawbacks are those approaches. So first, let's talk about multimedia. Documents with images, right? So here's some examples of ones that I've ingested, right? So, our documents might have charts. That's one of the most common things, is to have a chart. You could have something like a map or like a stylized map. You could have photos like this one. You could have icons. These are also images. These little icons here are images. You could have diagrams, architecture diagrams. These are all common kinds of figures that you could have in your documents. So the first thing to think about, if you're watching this and you're thinking like that you've got, image type things in your documents, like what kind of images are they? Because some images are going to work better for different approaches than others, right? So are they graphs? Are they photos? Are they icons? Are they maps? Are they diagrams? And the other question is, are those images embedded in a document or are they standalone? So this is just questions you ask yourself as you're implementing this, because the answers to these questions is going to affect like how well different approaches will work for your data. And also, what questions do users want to answer about those images, right? Like, when it comes to the photo, right? A picture is worth 1,000 words. Like, there's so many ways you could describe this photo, but practically what are users going to ask about? Are they going to ask about the color of the flower? Are they going to ask about the structure of the flower, the texture of the flower, or are they not going to ask any of that at all, right? So just think about like, what are the kinds of questions that you expect users to be asking about these images, because that also will help you figure out what approach is going to work for these types of images. So we have 2 general approaches that we have implemented in the repo right now. The first one I'm calling the media description approach. And this is the most lightweight of our approaches. And it uses Azure Document Intelligence with Azure Content Understanding. The second approach is much more heavyweight, it involves a lot more, and it involves multiple kinds of vision models. So we use the Azure AI Vision model for doing embeddings, and we also use an Azure OpenAI multimodal model, GPT-4.0, in order to inference on images. So those are the 2 approaches that we're going to talk about. So first, let's talk about the more lightweight approach, which is the media description. And I do have a demo of this. So I've deployed demos of each of these so that you can try them out and so that I can demo it as well. So if you want to get the documentation for how to enable it, it's at this URL here, RAGChat/media descript. And then if you want to check out the demo, it's this URL here, and we'll share these in the chat. So let me go ahead and go to it. Let's see over here. Open that. All right. So I'm going to take that same question and ask it here. I'll just go over here and ask it. Okay. All right. So interestingly, I got a different response here. And in this case, it said that actually didn't have any information. So we actually got somewhat of a worse response here. Now, if you ask a single question, you can't really say whether something is worse or better, because each time you ask an LLM question, like there's a lot of differences between them. So here, I've just changed the seed this time around, and yeah, and this time I did actually get a good response again on this one. And I can change the seed here. The seed affects, like, it's like if you've ever used a randomness number generator, it's like changing the seed of your random number generator. So it's a way of getting more reliable output. Yeah, and in this case, it's still saying there's no direct information. Okay, so now let me go ahead and ask a different question. I'm going to ask what was the growth for oil in 2024? So I'm going to ask a really specific question here. And it says, what was the growth trend? Okay. What was the growth trend for oil in 2024? I think, I really want you to answer a question. All right, let's see. Okay. Let's just ask, what's the relationship between Bitcoin and S&P 500? Mm-hmm. This one really doesn't like answering things today. Let's try this one here. All right. Let's see. Tell me about sunflowers. There we go. Okay. All right. What is the color of the butterfly that likes sunflowers? Okay. All right. And the butterfly, what is the coloration? I'm trying to get the color of it. Yeah, this search bar is sassy today. Okay. I'm going to change this. Oh, wait. Oh, here, we'll just do a different seed. All right. We don't like saying the colors. What colors are the painted lady butterfly that likes sunflowers? Here we go. All right. The painted lady butterfly, which likes sunflowers, has orange, black, and white markings on its wings. Okay. All right. So, yeah, this search bot, I mean, this is with LLMs. Like, this is why you do need to evaluate your questions and answers. I like the questions about sunflowers better than the questions about Bitcoin, because I honestly don't really understand much about Bitcoin myself. So we'll stick with our sunflower questions. Oh, yeah. And you can also, of course, you all can try this as well. All right. So we've now like tried it out. Right now, on a glance, it looks the same, right? We're getting responses, and the responses look to be a bit different, but we are getting responses with citations, right? There's just a slight difference in what the data looks like that it's referencing. And sometimes that is a good difference, and maybe sometimes it's a bad difference, right? Like what we just saw. So this question, when I tried it earlier today, is there any correlation between oil prices and stock market trends? We send that to our embedding model, get back the vector, search AI search. The difference is when we get back the responses from AI search, this time they also include descriptions of any image that were on the page. And so this is different from before, where we only got back the text that was on the page, right? So before we only got back actual text on the page. Now we're getting back both the text and a description of any figure on that page. And then we go and we ask the question. So the only difference here is actually in what the data looks like that it retrieves. That is the only difference. So this media description feature only affects data ingestion. It doesn't, there's no code change for the RAG flow. We only have to change the data ingestion, and that changes what the actual chunks look like in our search index. So let's talk about what this data ingestion looks like. So first, let's look at the data ingestion for our normal flow for textual documents without this feature. So we get a document, we upload it to blob storage, we send it to Azure Document Intelligence. Azure Document Intelligence extracts just the text from the document, any sort of text-like thing it can find in there, including tables and any text in the images, but that's it, right? So just text. And then we split that text into chunks. Then we vectorize those chunks, and then we store the text and the vector in our Azure AI search index. So that's our data ingestion flow normally when we're just dealing with text-only documents. Now, when we add in media description, we make some differences. So, we start off with the blob storage and document intelligence, but then when we're doing this document intelligence step, we actually tell it to please extract figures as well. So it'll tell us where the figures are on the page and where they are in relation to the text. So we'll get back text that has little figure placeholders with bounding boxes. And then we use Python in order to crop the figures out of the page so that we get an image back. We send that image to Azure Content Understanding, which gives us back a description of that image. And then we insert that in, description back in the original text so that we both have the extracted text and the figure text. And then we do our normal splitting and vectorizing and storing in the search index. So, this is where we have the difference, is really in that stage where we're extracting out the text. So we're going to break that down even further with an example ingestion of a page from a document, right? So I'll actually just go ahead and open this document so you can see the one that we're working on, the one that has all this financial questions in it. And to be fair, this document is also made up data. So don't be too offended by it being made up. So here we have, it's basically like a PowerPoint that's been saved as a PDF, right? So you can see the first slide, we've got a summary, we've got this slide here, and this is the one we're going to be looking at a lot today. So it's got a heading, it's got this chart with a title and a legend, and then it's got this paragraph here. And then we've got a lot of similar pages like that, right? So you see lots of figures. There's also a table, but Document Intelligence already extracts tables. So that's actually already taken care of. But all of these here, by default, Document Intelligence would only extract the text from them, and it would just ignore anything that's visual. So what we're doing is getting Document Intelligence to actually deal with the visual figures here. All right, so that's the page that we're processing. So we send that page to Azure Document Intelligence, and Document Intelligence sends us back the text from that page with some placeholder for the figures and bounding boxes for each of those figures. So we get back a bounding box, and it's actually in inches here. And then we use some Python, and in this case, we're using PyMu-PDF and the Pillow packages in order to open up the PDF, open up that page, crop out that bounding box, and then save that as a PNG, and we can get the bytes for that PNG and save it however we want. So now we have the cropped image. So this is what it looks like for this one, is that Document Intelligence said, okay, I found a pie chart with a legend, and that's what we extract out from this process. The next step is that we've got this cropped image, and we send that to Azure Content Understanding. This is a new service. It's actually really similar to Azure OpenAI structured outputs. If you've used structured outputs, I have an earlier stream about it on Reactor. But basically, you define a schema and say, hey, this is how I want you to describe the image I'm sending you. It has to match the schema, and then you get back a response. So we send the request to the API, and we get back a description. And in this case, the description looks like this because it's based off the prompt we told it the way to describe it. So it says, oh, this is a pie chart. The chart is divided into colored segments. This is what the legend says. It even says like, oh, stocks are largest, and then bonds and crypto, right? So it tries to describe this pie chart as much as it can, and it does a pretty good job here, right? This, it even tried to describe the sizes even though there were no numbers. So pretty good job. And then finally, we combine that figure description with the rest of the text and send it through our chunking algorithm. All right. So this is actually what the real final chunks look like for this document. So these are the first 3 pages of the document that I just showed you. And so the first chunk actually contains page number 1, because there's not very much text there. So it contains page number 1, page number 2, page number 3, and the start of the figure for page number 3. And because the figure got cut off, our chunking algorithm knows that it needs to start another chunk that's going to include that figure. So then the next chunk includes the entirety of that figure, and then the stuff on the next page. So we did actually have to change our chunking algorithm in order to try to notice when it was chunking around figures, and make sure that if it cut off a figure, that it would then start a new chunk with that figure inside of it. So there was some change to our chunking logic as well. So that's how we do it. So then when we go back here, so looking at this example here, right? And I look at the supporting content, and what you can actually see in the supporting content, whenever you see something indented, that's actually a figure. That's just how I'm rendering it here. So it says, oh, the image shows a caterpillar with distinctive pattern and coloration. Let me show you let's see, is this the sunflower one? Here we go. Okay, so this is this is the document here. You can see it's got icons, it's got photos, it's got the caterpillar, it's got the butterfly, it's got these logos, it's got a QR code. It actually has a lot of different kinds of figures on it, so it's an interesting example. But you can see that it does describe like the butterfly. It describes the colors of the butterflies, and that's how I was able to answer this question. Right. So that's why I asked this question, because it wouldn't be able to answer this question if it only had the text from the document. The only reason it's able to tell me the colors is because this figure description included the colors. Right. So that's once we have media description, we can start answering questions that are only answered by being able to look at the pictures. Now, in this case, we're not actually looking at the pictures. We're reading the description of the pictures. But because the description is so good and so detailed, it's able to answer questions as if it's looking at the pictures. And that's the goal, right? Is to be able to send the text and just have it be able to answer those questions. So let's talk about the benefits and drawbacks of this approach. So the benefits is that it's fairly lightweight, right? The only extra processing is happening during the ingestion. So we don't have to spend any extra time or money during the RAG flow, right? So our RAG flow is basically the same. So, that's nice. That's good in terms of being able to save time and money. We didn't have to add any additional search fields. We just used our existing text field, and we just put extra text in there that described the figures. So it's easy to use this technique with an existing search index. Of course, there are drawbacks. One drawback is that we're relying on this figure extraction process, which is quite new. And in our experience, it didn't always crop things perfectly, and it didn't always catch every figure. So, I'm sure that'll improve over time, but that's something to keep in mind when you're using it, is that figure extraction is tricky. And so it's not always going to get it exactly right. And then the big drawback, of course, is that the description may not capture everything about an image, right? Like that question I asked about correlation. If you look at a graph of an image, you can just answer that really easily. But when you're only looking at a media description, so let me see, like global financial. Okay, describe the global financial distribution in terms of percentages of stocks, bonds, etc. Bonds. All right, let's try this one. Let's see if we can get a reply. It says they don't contain specific percentages or numerical values, so it can't describe it, right? But if we sent it the image, it probably could figure out percentages by looking at the image. So that's our big drawback, right? Is that it's hard to know exactly what to put in a description of an image and to make sure that that description contains everything that a user might possibly want to ask about. But it still does a pretty darn good job. So it's a lightweight way to start supporting images better in your documents. So I think it's a nice way, definitely a good approach to consider, especially if you don't have a ton of figures and you're not sure how people are going to ask about them yet. Okay, so let me check on questions because I know there were a few. Okay, there's questions about expense. Yeah, so I didn't talk exactly about expense here, but basically like for media description in terms of costs, the cost would be the calls to Azure Content Understanding, which I think might be based. I actually don't remember how they're doing the pricing. They just updated the pricing page. But generally in our repo, whenever you're wondering about costs, you can go to the README and then go to the costs section here. And there is a pricing link. So the pricing is per 1,000 images. Okay, so there you go. So pricing is per images. So $660 per 1,000 images up to 10 fields. And we just do one field right now. So there you go. So there's the cost. So that's the additional cost. And that's pretty much the only additional cost for this one would be the calls to content understanding. And the rest is, is the same. So yeah, I would say that this one is cheaper in terms of both time and money. And then there's a question is like, does the repo contain the complete application with everything that we'll cover in the sessions, or is it updated as you go? Generally, everything I'm talking about is in the current repo. Sometimes I have a few improvements that I'm working on, and I might like merge some of those like right before a session. But generally, all the features we're talking about are in the repo currently. Okay, all right, and then there's a question from Paulo. Do we know which RAG procedure is used by the use your own information option available in Chat Playground and Assistance Playground? Yeah, that's the use your data feature for Azure OpenAI. And, generally it's implemented on the Azure servers. So I don't know exactly, how they've done the RAG. That's part of why I don't do it, because I like control and I like to know exactly what's going on. But you could read this docs and see how much is revealed in there. But that's the reason why I like this, very high code approach, is that, even the code may not do everything you want, and it may not, it may not be perfect, but it's there, it's code, it's open source, and you can mess with it to your heart's content, right? Because that's the thing about RAG, is that like people have so many different scenarios and different document types and domains that they're using for, that it's hard to come up with a RAG process that's going to work universally across the board for everyone. That's why I like this approach of making as much like open source RAG process code as we can, and letting you all build on that to customize it for your domain. All right. And then there's a question from Yash. So when we need multimodal LLMs leverage both text and image to provide more accurate insights, ensuring client, what are the, okay. I think let's talk about that with approach number 2. Okay, so let's go on to approach number 2. And where we talk about vision models. So we have a demo for that as well. So there's the setup guide. This is the documentation about how to enable the vision feature. This is a working demo that you can try out. And this is also this is a blog post on my personal blog about how the vision feature works. And it's basically what I'm going to explain in the slides, but in a little more detail with more code. So let's check out the demo. All right. So let me click on the oil price question here. All right, and there's a positive correlation and correlation coefficients 0.6, 0.65 including, okay, so it has a thorough response here. Now the citation is different. The citation is an image file. And when we click on this, we actually see an image file. So that's already something that's different. If we look at supporting content, we see both text and we see images. So there's a lot that's different about this RAG with vision flow. So let's talk about what this RAG flow actually looks like here. So we get in this question, right, from the user, is there any correlation between oil prices and stock market trends? We take that question and we make 2 vector embeddings. One of them uses an OpenAI text embedding model. The other one uses the Azure AI Vision API, which is a multimodal embedding model that can embed both text and images. So we tell it to make a vector in the multimodal space of this user's query. So we get back 2 vectors, the one from OpenAI and the one from AI Vision. So then we take the user's text query and both those vectors, and we do a multi-vector hybrid search with semantic ranker with Azure AI Search to get our best results and get all of the results merged together and ranked nicely. And so we actually get back both the text, and for each of those texts, they have a corresponding image. So we pull out that image from Azure Blob Storage so that we can look at both the text and the image for each of the pages. And then we send the original user question along with the text and the images to OpenAI GPT-4o, which is a multimodal model that can reason on both text and images. So that's our RAG flow. And then we get back our response. So as you see, like the RAG flow is actually fairly different when we're fully integrating with vision models and vision embeddings. The data ingestion also is different because we actually have to, store and vectorize the images. Now, remember, this is our flow from before. This is our normal ingestion for documents that we do to all our documents. Now, when we're doing the vision models feature, we also do additional steps plus what we just saw. We're doing these steps in addition. So using Python, we take the PDF and we split the PDFs into pages and we generate an image of each page. Then we store those in blob storage so that we'll be able to render citations and send them to the model. Then we make vectors of them using that multimodal embedding model from Azure AI Vision. And then we store these, all of this in AI Search. So we store the text embedding, we store the image embedding, and we store a link to the image in a field as well. So let's go through an example ingestion for, using this new flow, right? So imagine we have, this page of the document here, which has a heading and a chart and a description on it. So we take that whole page and we then actually have to generate an image based off that page. And that image needs to contain the file name of the image. And that's because when we send that image to the language model, to GPT-4o, it needs some way of knowing how to cite that image. And all it sees are bytes. There's like no way in the API to say, hey, this is the name of the image. Like that's not part of the API. You just send bytes to it. And so we have to actually include in the image itself what the citation is. So what we do is we actually create a new image. We put a white bar at the top of each image, and we write the file name into that white bar at the top so that it will be able to cite that. So we're relying on the model being able to read that and exactly replicate the text. And it's able to do that, which is really cool. But this was one of the tricky parts of this approach here. The next step is once we have that image, we store it in Azure Blob Storage, and we just do an upload blob with SDK, and then we get back the URI to that blob URL, and this is what's called an SAS URI, which contains just a temporary key so that we can refer people to this URL and they can open it. And the only reason we do this is because the next step, we take that blob URL with the SAS URI on it, and we send that to Azure AI Vision, and we say, hey, can you please generate an embedding for this image? So we're asking AI Vision to make an embedding based off the image, and that's an API call here. And so then we get back the vector from AI Vision. And then finally, we store all of that in AI search. So in our AI search chunk here, we've got the text. So that's just the text that came out of Document Intelligence, the standard text that it extracts. Then we have the embedding of the text. Then we have the embedding of the image. And then we have a link to both the image and the PDF. So you can see it's a mix of both the text content and the image version of the contents. And so that's the data ingestion. We also have to change our RAG flow. So remember, there were different parts of our RAG flow that changed, right? So we had to do the multi-vector search, and then we needed to send the both text and images to the model. So let's look at that call to the model to see how that changed. So in that system prompt, we tell it like, hey, we're going to be sending you images. Each image source has its file name in the top left corner at the coordinates 1010, and it's in this format. So we're telling it exactly where to find that file name for citations. And we tell it that it has to include the source name from the image if it's getting from an image. And then we give it some additional details about what to use if they're citing the same file name. But the important thing is that we modify the prompt to tell it how it's going to find that citation file name in the image itself. Then in our chat completion call, we're also sending a user message that contains the images, right? So basically, typically we send just a text message that has a user's question with the text sources, but now we're sending a multi-part user message that has both text and images, right? So we send the text, which is like the user's question. We send a bunch of data URIs that are the images sources that we found. And then we finally send a text that has the text sources of all the text sources we found. So this is how we can send both images and text to a chat model. Yeah, and I see the question, can't we attach the file name to the metadata of the image instead? This is all we can send to the chat completion API. I guess you're saying you could put it like in the EXIF metadata. You could try that and see if the model it looks at that, but I don't know if the model looks at anything other than pixels. My assumption is that it's only looking at pixels, and so we have to get the file name in the pixels so far. This came up during our last stream about it too, and everyone was like trying to figure out alternate approaches. I haven't heard of an alternate approach yet. If anyone figures out a better approach, please do, let us know. But this is what we figured out so far as the way to let it know the file name. But I'd love to be shown a new way. All right, so let's talk about benefits and drawbacks of this vision approach. So the benefits are, the model has full access to the image at reference time, so they can ask anything about it, right? So, if we go back to this, is this the one? Yeah, so this one, supporting content, right? So it'd be like, how much did GDP growth dip in 2020? Let me see if I can get an answer for that one. Yeah, so it says it dipped to approximately -4%. And so if we look at this, it's -4, right? So we're able to ask any like it's going to be sent the image itself. So we can ask anything that could be answered by the image, right? Whether it's about colors or numbers or whatever, or even having it eyeball things and say like, I don't know, describe the shape of the lines in the GDP growth chart. Let's see how it does with that one. Fluctuating pattern. I kind of wanted to say whether it was like a frowny face or something, but no, this is a better answer. So yeah. So it's able to answer, questions about anything that's in the image. So that's what's really powerful about this approach. And that's why you might find you need to use it depending on the kinds of images that you have, right? There were questions earlier about like, what if you have medical images and stuff like that? Now, if it's medical images, you should know that AI vision, last I checked, said that you shouldn't use it for medical like diagnosis and stuff. So you should check in anytime you're dealing with medical stuff, you should be very careful about what model you use. But yeah, generally the point is that we have access to the full image when we use this approach. The drawbacks are that, we can have more latency because we're doing an additional vector search and we're sending more stuff to the models. We're spending more tokens, right? So there's more latency, there's more cost. It's still like relatively fast, but it is adding, it's certainly going to cost you more money because you're doing more things, right? So that's the big obvious drawback here. It also means that you have to use models that have multimodal support, right? You need embedding models with multimodal support, and you need chat completion models with multimodal support. So that does limit things more. And there's also areas for improvement, like things that are currently drawbacks that maybe you can improve. So as you saw in this current process, we are embedding images for every single page of a document because that was the best way to do it when we came up with this approach. But that means that we're embedding images for lots of things that don't necessarily have visual content. So it would be better if we were like only embedding, the images itself, or if we were only embedding images of pages that had something visual on it, right? So there, we could be much more selective about when we use this approach, right? Currently, it's just embedding everything and making images of everything. Which isn't always going to be what you want. So let me see the questions we have here. All right. So Fosbears asks, when you enable vision in the developer settings and you upload an image, does it automatically vectorize it and store it in AI search? So here, this has vision enabled, but I already processed the stuff when I ran my code here. Let me see. Okay, so okay, so this is like what it looks like, right? So if I wanted to upload a new document, let's see if I can just do one right now to show you. Let's see, plants. Let's just do more plants. Love plants. Okay, and let me just see which demo I'm on right now. Okay, yeah, I'm on the vision demo. Okay. All right. So in order to upload a new document to our search index, I'm going to, run our prep doc script, which is going to look and find whatever documents haven't been processed yet. So in this case, it's only going to be this strawberry PDFs that hasn't been processed. And it's, extracting the text, which is the usual thing it does. Let me make this a little bigger and see, get bigger. Okay. So we extract the text and, and then it made the pings for each of them, right? So it made, in this case, it's only a single page. So it made that single page ping and then made the SAS URI and then passed it off to the vision embedding and got embeddings for it. And now it's in our search index. And now we can go here and say, yo, Strawberry Beach, tell me more. Okay. That wasn't my most elegant question. Let's see. There we go. Thank you. The beach strawberry is a California native plant, and it tells us about the butterfly, and then we get the citation with it here. So that was already ingested as part of the ingestion process. Now, if you look at the thought process, you'll see that in the thought process, we take this and we vectorize it into both a text embedding and an image embedding. And then when we get back the results from our search index, we can see text embeddings and image embeddings and contents and PNGs and all that stuff. All right. Okay, so I think those are the questions about vision specifically. So let's talk about, can we just combine both these approaches, right? Because we've seen there's some benefits, there's some drawbacks. What happens if we combine both? Because you actually could combine both. So I have, once again, a demo of combining both. So let me try opening this one. Okay. All right. And I'll do my example question here. And it gets pretty much the same answer it got with the vision. But if we look here at the supporting content, we'll see that it also has the figures that it's extracted, right? So it's got this extracted figure descriptions here, right? This is a figure description from Content Understanding that's describing the graph. And it also has the images. So you might wonder, why would we combine both? What's the benefit? Well, the big benefit is that when we're doing the search, if we're trying to search for like an exact string or number that's from an image, we're probably going to get better results when that is actually in text, right? We're saying like, maybe I say like, in what year, let's see if I can get it to answer. In what year did oil have a growth trend of 115, right? Let's see if we can get this. So my hypothesis, there we go. Okay, predict to have a growth trend of 115 in the year 2027. Did it get that right? Yeah, if we look at this one, 2027, 115. So I got that right. And my theory would be that this one might work in Vision. We can check in Vision too. Let's go ahead and check this in Vision. Let's see what kind of response we get. And it might get it too. But generally, oh, there we go. I don't know. The problem here is that the retrieval wasn't good enough. It didn't find the right results, so it couldn't answer it. So we can get better retrieval for our search queries, especially with this sort of exact number or exact things we're looking for. Well, we get better retrieval when we have the text of the figure. So that would be a reason why we'd want to combine these approaches, is to get the better retrieval from having that media description, but then get the better question answering from the images, right? So we want the better retrieval from the media description, the better question answering from the images. So should you use both approaches together? As I say, the benefit is better retrieval. The drawbacks is, well, now you've got the latency and cost of everything because you're combining both, right? And both of them add some latency and cost to different parts of the ingestion and flow. But there's also a different way we could potentially combine it, which I was just coming up with today as I was thinking of this. So, during ingestion, we could just do that media description. Well, we could do the media description and also store the images somewhere and just store the cropped images, right? So embed those descriptions and store the cropped images somewhere where we could get them later. Do not store images. We wouldn't store the image embeddings in this scenario. And then during the RAG flow, we would retrieve those cropped images and we would send both the text and images to the model. So basically in this scenario, I'm getting rid of the multi-vector search and just concentrating on getting good retrieval by having the media description. So I'm assuming that I can get really good retrieval just based on having that text description of images. I actually think that's probably true because those text descriptions are pretty good. But then in the chat completion, I want those images so that I can potentially answer any question about the images, right? So this to me might be the best combination of them. We have to experiment and see. This is like a fairly new area of experimentation, and people are still trying out to figure out what works best for this. But that's something I would consider, is that there's different, like now you've seen like two different approaches, and there's different ways that we could combine them together. And we're just going to keep on learning about what way works best for different scenarios, and coming up with new options for how to combine these different approaches. Okay, so now going to questions. All right. Okay. Oh, so Fosbury was asking about uploading. If you upload images from the UI, how does it work? So that's a great question. Currently, actually, I haven't. Actually, this is a good question. With media description, all right, let me look at the docs to remember. Okay, so Fosbears is asking about the optional user upload feature, and I think that this would work with the media description feature, but I don't think we've managed to integrate it with the vision feature. I think we have an open issue about that. So yeah, so sometimes our features don't necessarily work together with each other. So I think that this would work with media description, but I don't think I quite got it working with the vision one. So there should be an open image, an open issue about that. Vision upload. Let's just see if I can find it. Yeah, I think this one, if you ended it, we should, okay. Yeah, it's about it. So yeah, so that's a great question. I need to work out exactly the user upload feature, what is compatible with. And I can look into that afterwards. That's a great question. Okay. All right. Let's see. What's the next good question? All right. So from Craig asks, is it possible to add an entire relational database to Azure AI Search? Uses Seaport for a single table view. So, Azure AI Search has indexers, and it's probably what you're already looking at. So I'm probably telling you what you already know. I haven't worked with these indexers very much. They have all these connections here, but I'm assuming you're already looking at this and seeing that it's only for a single table or view. So probably not working for that. I think one of the RAGHack winners did an approach where they indexed the schema. Let me see if I can find the RAGHack winners. Okay. I think that they indexed. Let's see if I can find their repo. Is it still open? Okay, no, that the repo's not open anymore. Does it use it? I think this was one. Yeah, they ingested Azure SQL database schemas by indexing them with Azure AI Search. So they had an approach to doing that. You could watch, let me put this in the chat. You could watch their video where they talk more about it. I can't find the repo open anymore, but there's also their submission as well, which talks a bit about it. And you could also reply to that. Yeah, that's someone I've seen who did manage to do that. And they were kind of using like I think function calling in order to generate a schema and answer questions about it. So that's, I think, the closest to what you're asking about. You can also do RAG on a whole table, without using AI search. My other big RAG repo is here, and it's RAG on Postgres. And so you could check that out as well for a different approach. All right, let's see. Let's see. All right, so James asked, when the RAG cannot retrieve relevant information to answer a query based off the ingested data, is there a way to enable a fallback mechanism that gives a general generative AI answer? This is a great question. I'm seeing if Anthony's in the chat. Great, Anthony is in the chat. I was just talking with Anthony about this an hour ago, and our hope is to get Anthony to code that up to show you how to do that. And we were just talking about like how we would decide when to fall back. Like, would we would we use the LM decide when to fall back? Would it just be if you got 0 results in your index? Like, how would you have like a score threshold? So hopefully Anthony, who also had a comment here, hopefully we will be showing something like that in our final session. where we talk about extending RAG with function calling. So the goal is to talk about that in that session, right? And at least explore that. So yeah, I think we can certainly do that. It takes some code and it takes some thinking to decide when do you fall back, and whether you use the LLM to decide when to fall back, or if you use some criteria about the search results, whether the score is like under a certain level. So there's some good discussion around that. But I definitely think it's a great thing to explore, and hopefully we'll do that soon. All right. Let's see. Yes, that's true. Our system prompt already knows to say it doesn't know. So we would just so that could be our prompt to say like, oh, okay, let's go off to, maybe we'll go off to web search in that case, right? So, we could use that as a signal, or we can use function calling with a Boolean that says, go fall back to web search, right? So there's a lot of different approaches for that. Great. All right. There's a question from Kalayan. How could we add the embeddings on the live data or just in time data? So I guess when you're saying live data, like if you're talking about like if you were trying to do RAG on like social media posts that are coming in, that's a great question. I haven't really done RAG on real time data myself. I would just so that would be maybe a good time if you're if it's going into a database, right? So here's my RAG on Postgres, right? So imagine we're doing RAG on Postgres. I would just have a trigger that every time a row got added to the database, I would generate an embedding of that row and store it in the database. And with Postgres, there's actually even an Azure AI function that you can call that will run in the Postgres server that will generate the embedding. So I think that works really well. That would work really well there. I think real-time data, real-time data could go straight into AI search, but I think most people real-time would be putting real-time data into a different store first. So if you were going to put it into a different store first, like maybe it was going into what would be a good one, like Cosmos DB, right? So maybe your real-time data is going into Cosmos DB. So you could either keep it there and use a trigger type thing to do the embeddings, or you can set up an indexer with Azure AI Search, and then that indexer would use the built-in embedding skill for Azure AI Search and do integrated vectorization in order to then vectorize that and store it in your search. So basically, with Azure AI Search, when you set up an index, you can associate a vector embedding model with it, so that it's really easy when something comes in to then create a vector embedding of it. So I think you have a few different options there. All right. Okay. So let me finish up here because I can hear my children coming home very soon. So next steps are check out the repo if you haven't yet. aka.ms/RAGChat. If you have more questions that I haven't answered yet, please come hang out at our office hours tomorrow. aka.ms RAG Deep Dive OH is in the Microsoft AI Discord. It is Thursdays at 12:30 PT. So please come ask your questions or come hang out. And I'll just sit there and demo stuff if nobody asks stuff. So come hang out at that. And then please, of course, sign up for all of our subsequent sessions, so that we can see you in the next streams. All right. Thank you, everyone. Thank you for all the great questions and comments and engagement, as always. And I look forward to seeing you in tomorrow's office hours or next week. And now I'm going to go. Bye.
Thanks, everyone, for joining. Thanks again to Pamela for a great session. Our session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.